All right, so note 6.4 are on finding missing sides of right triangles. And I don't have any list of steps that I want to give you. I just want to go straight into it for for these examples here. And I really want you to understand why we're doing what we're doing. So what we're going to do here is we want to solve for x. This is a missing side length that I don't know what it is. So I'm going to use the angle that's given to me, and I'm going to see how the side that I want to know and the other piece of information that I'm given relate to this angle right here. So if my right angle is here, that tells me that 7 is my hypotenuse. And then because the x is right next to this angle right here, this x is the opposite. And now I'm going to just write out SOHCAHTOA. And we want to look in SOHCAHTOA and find the ratio that's going to use A and H. So sine uses opposite and hypotenuse. So I don't want to use sine. Cosine uses adjacent and hypotenuse. So I definitely want to use cosine. Tangent uses opposite and adjacent. So I don't want to use tangent. So I'm going to use cosine right here. So I'm going to say the cosine of the angle that I am given, which is 29, would be equal to, by the way, when you do this, you always have to say cosine of some angle, okay? So cosine of the angle, which is 29 degrees, so cosine of 29 degrees is going to be equal to adjacent, which we know is x, over the hypotenuse, which we know is 7. So I'm going to say is equal to x over 7. Okay, now in order to solve for x, all I need to do is get rid of this divided by 7. So the opposite of division is multiplication. So if I divide by 7 here, I can multiply by 7. That will cancel it out. But whatever I do on one side, I do on the other side. So here I get x equals 7 cosine of 29. Once I do that, I can go to my calculator. I'm not going to go to my calculator at any other point in time until I get this piece done right here, until I get the x completely isolated. Now that I've done that, I can go straight to my calculator and type in 7 cosine of 29. And then it says to round to the nearest thousandth. So let's go ahead and do that. So I'm going to type in 7 times the cosine of 29 degrees. Make sure you are in degree mode and not radian mode. And we get 6.122. So we know that x here is going to be approximately 6.122, and we have solved for x. All right, in our next example, we're given angle 48 degrees, and the opposite side to it is the x, and then the adjacent side to it is the 5. How do I know that this is adjacent? Because this one is going to have to be the hypotenuse, okay? So which ratio uses opposite over adjacent? That is going to be the tangent ratio. So right here, I'm going to say tangent of 48 is equal to the opposite over the adjacent, so x over 5. The order matters. So in order for me to solve for x, I'm going to multiply both sides by 5, cancel it out on both sides. So I end up getting x is equal to 5 times the tangent of 48. So now I can type it into my calculator because the x is completely isolated. So I will type in 5 times the tangent of 48, and I get 5.553 approximately. And that's how we do question number 2. All right, and number 3, the angle that's given to me is this 32-degree angle. Here is the hypotenuse. So I don't really care about the hypotenuse, to be honest. This is the opposite, and this is the adjacent. So this is where things will get a little bit trickier, and I want you to pay really close attention to this. So I'm going to write out SOHCAHTOA again, and I know that tangent uses opposite and adjacent. So I'm going to use tangent again here. So I'm going to say the tangent of 32 degrees is equal to the opposite, which is 9, over the adjacent, which is x. And this is what I'm talking about where things get tricky, because the x is now in the denominator, when in the other two examples, the x was in the numerator. But it's the same exact idea. I want to get rid of that 7 out of that denominator. I want to get rid of that 5 out of that denominator. I also want to get rid of this x from this denominator here. So that will cancel this x with this x. So I get x tan of 32. So because I get x tan of 32 equals 9, I have not fully isolated this x yet. So now what I need to do is get rid of this tan of 32. And because this is multiplication, the opposite of multiplication is division. So I'm going to do 9 divided by tangent of 32. Okay, let me just show you here a little bit more in detail what it is that I did. So to get rid of this tan of 32, I divide by tan of 32. Whatever I do on one side, I do on the other, and that's where I got this piece from. But I'm going to skip this step from now on when I'm showing my work. Okay, so let's go ahead and type that into our calculator. So I'm going to take 9, divide that by the tangent of 32, and I end up getting 14.403. So x here is approximately equal to 14.403. Okay, and then in number 4, there's a typo. I'd like you to please find BC. So cross off BD and change it to BC. So this is the side length that I want to figure out first, BC, and then I want to find AB after that. So this is going to require 2 steps from us right here. So the first thing I want to do is find BC. And also there's a right angle here. You are not to assume that there's a right angle, but I'm telling you that there is one, okay? So I'm going to take a look at my right angle, my right triangle, on the right side right here. So if you notice, here's my angle 60 degrees. The x right here is the opposite and the 8 right here is the adjacent. And so I would always use tangent if there's opposite and adjacent. So the first thing I'm going to do is find BC, which is x. So we're going to use the tangent of the angle that we know, which is 60 degrees, is equal to the opposite, which is x, over the adjacent, which is 8. So I'm going to multiply both sides by 8 to cancel that 8 out. So I get 8 tan of 60 is equal to x. The x is completely isolated, so I can go straight to my calculator. So I'm going to type in 8 times the tangent of 60, and I end up getting 13.856. So here I get x is approximately equal to 13.856. Now that I've done that, the next thing I want to do is find AB, which is this side length right here. So I can use this triangle right here to help me out, especially because I know that this is 45 degrees. So to find AB, which is y, we are going to say that the x, which is now known, we know it's 13.856, is still the opposite, and the y is the hypotenuse. So here I would use sine because sine is opposite over hypotenuse. So here I'm going to say sine of 45 is equal to the opposite, which we now know is 13.856. And that's going to be over the hypotenuse, which we don't know. So to solve, we have to multiply both sides by y. So I get y sine of 45 is equal to 13.856. And I apologize, we're going to have to squeeze this in somewhere. Why don't we bring this down here? So here we can say that that y is going to be equal to 13.856 divided by sine of 45, which is approximately 19.595. So here we know that y is approximately 19.595. So now we can say here, therefore BC is equal to 13.856, and that AB is equal to 19.595. And that is our final answer. All right, so now we're going to talk about applications of trig. So the first thing it says is what to do with trig applications. And what we do is we always draw a picture, because once you draw a picture, the rest is easy peasy. Okay, we need a few definitions though. So the angle of elevation, my friends, is going to be in a right triangle right here, or even if it's not a right triangle, this right here, this one is the angle of elevation right here. So this is the angle of elevation. Now, that might seem weird because when you hear the word elevation, you might think up high. So you might think that it would be this angle up here. But that's not the angle of elevation because it is showing you what it is going up by. So it has to start at the bottom and go up. If it starts up here and goes down, then it is decreasing. Okay? So what is the angle of depression then? Wouldn't this be the angle of depression? If only it were that easy. So the angle of depression is actually this angle right here. So this is the angle of depression right here. So there's two ways that you can figure this out or use this to help us out in the triangle. So like, let's say, for example, my angle of depression right here was 30 degrees. Then we could say that this right here would have to be 60 degrees because this adds up to 90. We can also say that we know that this is 30 degrees because of the Z pattern or alternate interior angles. So this angle would always be equal to this angle. So the angle of depression is also this angle right here as well. Okay? So let's try it. Label each diagram with below with the angle in the appropriate location. So in question 8 says the angle of inclination of the stairs is 40 degrees. So this right here would be 40 degrees. Okay. In question B, it says the angle of depression to the tank is 35 degrees. So it's going down. This right here would be 35 degrees right here. So this angle right here makes 35 degrees, which means that we can automatically assume this is 35, or we can also say that this would have to be 55 because 90 minus 35 is 55 degrees. Okay, and then the last one, it says Justin sees a flag at an angle of elevation of 42 degrees. So this right here is our angle of elevation. So let's apply this. Question number 6, the angle of elevation from a point 36 feet from the base of a tree. So I'm going to highlight my key information right here. Angle of elevation, a point 36 feet from the base of a tree on level ground to the top of the tree is 22 degrees. And we want to calculate the height of the tree. So if you take a look right here, this is my tree. Okay, and the angle of elevation from a point 36 feet from the base of a tree, so the base is at the bottom, this is 36 feet. The angle of elevation, so we've got a right angle right here, is 22 degrees. Calculate the height of the tree. So we want to figure out what this height of this tree is right here. How tall is my tree right here? So now that we've drawn our picture, the rest is nice and easy. We know that this x is the opposite. We know that this 36 is the adjacent because the hypotenuse is across from the right angle. And using SOHCAHTOA, we know that we are going to want to use tangent. So here we can say the tangent of 22 degrees is equal to x over 36. Now to isolate that x, I'm going to multiply both sides by 36. Whatever I do to one side, I do to the other. So x is going to equal 36 tan of 22. Then I'm going to type that into my calculator. So I can type in here 36 tan of 22, and I end up getting 14.544. Since it says to round to the nearest foot, we're going to say 14.54. Okay? So here we can say that this is 14.54. So therefore, the height of the tree is 14.54 feet. So in number 7, it says a man at the top of a cliff looks down at a pond. So there's a man, he's at the top of a cliff, he looks down at a pond. The cliff is 25 meters in height, and the angle of depression from the top of the cliff is 30 degrees. Find the direct distance between the man and the pond to the nearest meter. So we can see here that this will be our cliff. The man is standing up here, okay? We also know that there is a pond that he's looking down at. So this right here is the pond that he's looking at, okay? And so he's looking like this right here down at the pond, and this completes my right triangle right here. It says the cliff is 25 meters in height, so I can label this as 25 meters. And the angle of depression from the top of the hill is 30 degrees. So I know that this right here is 30 degrees. Find the direct distance between the man and the pond to the nearest meter. So right here, I know that I want to find the distance from the man directly to the pond. So that is the value that I'm trying to find right here. If you notice, this 30-degree angle is not inside of my triangle, but I do see that I have the Z pattern or alternate interior angle. So I can also say that this is 30 degrees. By saying that this is 30 degrees, we can say that this is the opposite and that this is the hypotenuse. So I can say sine of 30, because sine uses opposite over hypotenuse, is equal to 25 over x. Multiply by x on both sides to get that x out of the denominator. I get x sine of 30 equals 25, but my goal is to get that x alone. So I'm going to divide both sides by the sine of 30, and I get 25 over sine of 30. So let's go ahead and type that into our calculator. So 25 divided by the sine of 30, and I get exactly 50. So x here is 50 meters. Okay. Another option that you have is you could have said that this angle inside of here was 60 degrees because 90 minus 30 is 60. That would change what this is here because it is no longer going to be the opposite. We'll talk about this a little bit more next time I see you in class, but that's it for this video. Let me know if you have any questions. Otherwise, I'll see you in class. Bye.